want you to pause the video and evaluate 2 minus 2 square root of 3I raised to the power of 6 using de Moivre's theorem. Okay, finished? Let us see something here. Now you remember that when you have this form of a complex number is in rectangular form, what you need to do is convert it to polar form. Alright? Now, if you want the polar form, we imagine our graph here. Go to 2 minus 2 square root of 3. So it's somewhere there. So it would end below 2 and below negative 2 square root of 3. Alright? Now, we want to find out what is the angle. Remember, positive angles are measured in an anti-clockwise direction, so we need this angle, theta, and we need r, the magnitude of the complex number. Alright? So here now, what we can do to get the radius, we can say, imagine that we have a right angle triangle here. We find this angle, call it alpha, same thing as this, and then we're going to take it away from 360 to find the remaining angle. Or let's work in pi, in radians. You could work in degrees or radians. All right. So suppose you work in radians. I could even do both of them. So here, what you have is this is 2, the length of this is 2, and the length of this is 2 square root of 3. Now, tan of alpha would be opposite 2 square root of 3 over adjacent 2. So alpha would be tan inverse of 2 square root of 3 over 2, right? So alpha would be what? Let us use our on-screen calculator and work it out. Alright, so we have our calculator here. 2 square root of 3 over 2. 2 times square root of 3 equal, and that over 2 equal 1.732. Alright, 1.732. Alright. Now, tan inverse of that. What am I doing? Alpha equals the tan inverse of that. So I want to find the tan inverse of that angle. Right? So we say tan inverse of that angle equal, well, 60 degrees. Now, 60 degrees. What we want is radian. How do I put this calculator in radians? Radian. When it comes to this calculator, I'm not sure how to put it in radian mode from degree. I see some unit conversion here, but I don't see a radian mode business here. Well, you should be able to put your calculator in radian mode. Now, since we don't have our calculator in radian mode, let's convert it ourselves. 60 degrees is how many radians? Remember, 360 degree is 2 pi radians. So if we divide both sides by 360, 1 degree is equal to 2 pi over 360 radian. That's if you're asked to do it in radians. You'll use a calculator. Hopefully you'll be able to put it in radian mode, unlike my calculator there. So 60 degrees multiply both sides by 60 is 2 pi over 360 times 60. 60 into 60. This is 6. 2 over 6, which is 1/3 pi. Alright, so alpha is 1/3 pi radians. Now remember, this is the angle here is alpha. What we want is the angle around it. So what we do is subtract it. If it was in degree mode, we would subtract 60 from 360 to get 300 degrees. But if we're working in radians, what we will do is say 2 pi radians 1 minus 1/3 pi radians is pi times 2 minus 1/3 is what? 2 over 1 minus 1 over 3. So it would be 236 over 3 minus 1 over 3, which is 6 minus 1 is what? 5. 5 over 3 pi radians. Alright? So that's will be 300 degrees. Let's try a little thing here. So we see that 1 degree is 2 pi over 360 radian. So 300 degrees would be 2 pi over 360 times 300 radians. We cancel down 3 into 30, 10, 3 into 36, 3 into 3, 1, 3 into 6, 2, 2 into 2, 1, 2 into 12, 6, 10 over 6 would be the same as 5 over 3 pi. So we'll see, it's correct. Alright, we subtract 2 pi minus 1/3 pi would be similar to 360 minus 60 degrees. We also converted 300 degrees to radians, and we get 5 over 3 pi. Alright, so it's 5 over 3 pi radians is our theta. 5 over 3 pi. I'm just imagining that you are asked to work it out in radians, right? If you have a calculator, just put it in radian mode, find the tan inverse of this, you would get 1/3 pi. 1/3 pi would be the same as pi over 3. You should get what? Let me use a calculator here. 1.47 something. And then when you find 5 over 6 pi, 5 times pi over 6, you would get 2.62 something another. Alright, but anyway, what is the magnitude of the complex number here? Let's see if you can figure that out. Now, here, we use Pythagoras theorem, because this itself, is a right angle triangle. So, r squared is equal to 2 squared plus 2 square root of 3 squared, which will be 4 plus 2 is 4, and square root of 3 squared is 3, which would be 4 3 is 12, 13, 14, 15, 16. Square root of 16, which is 4. Right? I mean, this is r squared, 16. So r would be square root of 16. Let me redo this part. R squared is 16. So r is the square root of 16, which is 4. So r equals 4. Alright? So, remember now, you're going to convert it from rectangular to polar form. Now the thing is, how do we convert from rectangular to polar form again? Well, we have the magnitude of the complex number and we have the angle. Now, remember, if you have a complex number looking like this, let me draw it using straight lines. We have this complex number. We have theta. We have r. Now, this is the opposite. Sine, call this, for now, call this y and call this x. Sine theta is opposite y over hypotenuse r. So y is equal to r sine theta, right? So this is r sine theta. Cosine theta is adjacent, x over hypotenuse is r. So x is equal to r cos theta. So this is r cos theta. Remember that? Now, what we have here is the complex number. This is the real axis. We have the real axis and the imaginary axis. So this would be the I imaginary axis, alright? So the real number here is r cos theta plus I r sine theta. Remember that? So that is the complex number that we have, right? Sometimes it's written using a shortcut, r angle theta, right? I won't be using the shortcut right now. So, here now, what we really have is r. Oh, by the way, let's just factor out the r now. Cos theta plus I sine theta. Look a little bit neater that way. So here, our r is 4. So our complex number here is 4 cos in radian mode is 5 over 3 pi, or 5 pi over 3, same thing as 300 degrees, plus I sine 5 pi over 3, right? We have our complex number in polar form now, from rectangular form to polar form. It was 2 minus 2 square root of 3i in rectangular form. It is 4 cos 5 pi over 3 plus 4 I sine 5 pi over 3 in polar form. But the thing is, this is raised to the power of 6. Now in polar form, what you have, this, it will so happen that you have 4 to the power of 6 and the angle will be multiplied by 6. So it's cos 5 pi over 3 times 6 plus I sine 5 pi over 3 times 6. That's what's going to happen. So what is 4 raised to the power of 6? I have 2 calculators here. I just need one. 4 to the power of 6 equal 4096. So we have 4096. Then we have cost. Now this is 3 into 6 goes 2 times 2, 5, 10, 10 pi plus I sine 3 into 3, 1, 3 to 6, 2, 2, 5, 10 pi. So that in polar form is a complex number raised to the power of 6. Now let's put it back in rectangular form. They asked us to put it in rectangular form, so we assume that it's rectangular form they want the answer in. So remember, this is radians, but since my calculator cannot be put in a radian mode, well, so far as I understand it, let's convert these to degrees, right? And then put this back in rectangular form. So we have 4096 times cos 10 pi. Pi is the same as 180 degrees. So this cos 180 times 10 is 1800 plus I sine 180 times 10, 1800 degrees, right? Remember, pi is the same as 180 degrees. One complete revolution is 2 pi r, 2 pi radians. Half a revolution, well, the one complete revolution contains 360 degrees, which is 2 pi radians. So half a revolution contains 180 degrees, which is half a 2 pi, which is pi radian. So you have to remember that 180 is the same as pi, right? Alright, so here we have 4096 times what is cos 1800. Let us see. Cosine of 1800 equal 1. And the sine of 1800 equal 0. So what we have is 1 plus 0, which is 4096, right? Just that, 0i. So what would happen? If you want to get that, you'd have to have 6 of these and spend the whole day multiplying out all of them. But you convert it to polar form, and remember that the magnitude is raised to the power of 6 here, and the angle is multiplied by 6, and then you convert it back to rectangular form. So you can write this as 4090 plus 0i if you want. It's 4096 plus 0i if you want. But the answer here is 4096.